Hello everyone. In this video, I will explain the coplanarity of three or more vectors or 4 points in vector algebra. Particularly, coplanarity of vectors in vector algebra is very important. You can find plenty of questions in previous JEE main questions. So if you can solve 2-3 questions very carefully by listening this video, no doubt everyone can solve remaining questions by their own way. So what is the most popular concept of coplanar of vectors? Here, see, I have taken 3 vectors. A bar equal to A1i plus B1j plus C1k. This is the first vector. Second vector B bar equal to A2i plus B2j plus C2k. And third vector C bar equal to A3i plus B3j plus C3k. With 3 vectors. Then we know the definition of A cross B dot C. A bar cross B bar dot C bar. We denote it by box of A bar, B bar, C bar. So I am explaining this concept using the box. So the box of A bar, B bar, C bar is nothing but determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3. Right. Well, so now, what is the condition for 3 vectors to be coplanar? What is the condition for 3 vectors to be coplanar? So here I am writing that A bar comma B bar and C bar, right, if these are coplanar, if and only if box of A bar, B bar and C bar equal to 0. Of course, we can explain using system of equations also, but to understand the concept, this becomes very simple. So, how do we prove that 3 vectors are coplanar? Then box ABC equal to 0. And of course, vice versa. So now you see, so here I am providing the proof. Proof is quite simple. Suppose, so coplanar vectors means they must lie on same plane. Suppose A bar, B bar, C bar are coplanar. Then we need to prove that box of ABC equal to 0. Coplanar vectors means they must lie on same plane. Like if you take 3 vectors on one of your walls in your house, then they all lie on a same wall. So they are coplanar. So here A bar, B bar, C bar given that are coplanar vectors. Then we need to prove the condition that box of A bar, B bar, C bar equal to 0. So now you see. See, this is assume A bar vector and assume this is B bar vector, right? So here given that A bar, B bar, C bar are coplanar vectors. They are coplanar vectors. So coplanar vectors means they all must lie on same plane, same plane. So here I am taking, this is another vector. This is C bar vector. Remember, in fact, they need not to meet, but by moving those vectors, we can make them to meet at a point. So here you see, this vector is perpendicular to A bar and B bar. So this is A bar cross B bar, which comes out. Okay. So now you see C bar lies on the plane of A bar B bar, and A bar cross B bar is normal to the plane. Is normal to the plane means this is the plane and this is the normal. So now this pen is perpendicular to every line which lies on my hand, you see, on my palm. So similarly, now A bar cross B bar is perpendicular to C bar. Very easy to understand this concept. That diagram explains everything. Suppose these are coplanar. Then this implies that A bar cross B bar, A bar cross B bar perpendicular to C bar. It is very simple. A vector perpendicular to A bar and B bar is A bar cross B bar. So now A bar, B bar, C bar, they all lie on a same plane. They all lie on a same plane means you can consider it as a wall, one of your walls in your room. So you draw three lines or three vectors in a wall. Now a vector perpendicular to A bar and B bar is A bar cross B bar. So that is also perpendicular to C bar vector because C bar vector lies on the same plane and A bar cross B bar is normal to that plane. So this is perpendicular to C bar. So this implies A cross B dot C bar equal to 0. So which means that box of A bar, B bar and C bar equal to 0. So it is a just application of determinant. So this implies determinant of A1, B1, C1, A2, B2, C2 and A3, B3, C3 equal to 0. So just it is an application of very simple 3 by 3 determinant. So three vectors are coplanar, then their determinant equal to 0. We can prove in reverse also. Here I am writing. Okay, conversely, suppose box of A bar, B bar, C bar equal to 0. Now we need to prove that A bar, B bar, C bar are coplanar vectors. So this implies the meaning of this statement is A cross B dot C bar equal to 0. Well, so which means that A bar cross B bar is perpendicular to C bar vector. And how is A bar cross B bar to A bar and B bar? And we know that A bar cross B bar is perpendicular to A bar and B bar. So this is A bar vector and this is C bar vector, and this comes out, this is A bar cross B bar. Now you see C bar is perpendicular to A cross B. C bar is perpendicular to A cross B. So C bar is perpendicular to A cross B is nothing but C bar must lie in the plane of A bar B bar. Otherwise it is not parallel. If you bring out C bar outside of the plane A bar B bar, then it will be parallel to A bar cross B bar. So this implies, so C bar must be in the plane of A bar and B bar. So this implies C bar must lie in the plane of A bar and B bar. Because here you see A bar cross B bar is perpendicular to C bar. So which means that like this is the A bar cross B bar. This is A bar cross B bar. Now you need to draw a vector perpendicular to this A bar cross B bar, which means that it must be lie in the same plane, or you can say one of my fingers is perpendicular to this. So this one of my fingers is nothing but that is C bar. So C bar lies in the plane of A bar and B bar. C bar must lie in the plane of A bar and B bar and C bar. So this implies A bar, B bar, C bar are coplanar. So I have just provided the proof of this theorem. In fact, proof is not at all necessary. So, but we need the core concept. If we do not understand the proof of this theorem, simply by applying the determinant blindly, somewhere we may stuck in any question. So that's why we must have a clear interpretation in understanding of any kind of concept. Now, so I have just proved that three vectors are coplanar. So three vectors are coplanar is nothing but this box or determinant is equal to 0. So this determinant equal to 0. Whenever person comes, whenever they say three vectors are coplanar, immediately apply that determinant equal to 0 and expand the determinant, you will get the answer. So now, sometimes instead of vectors, they may give points also. This is also important. So here you see that 4 points A, B, C, D. 4 points are given. Are coplanar. 4 points are coplanar means they must lie on same plane. You can take 4 points on a wall. So they are coplanar if and only if box of AB bar, AC bar and AD bar equal to 0. Very simple concept. Now you see, so this is the plane. I have taken 4 points on a plane. Now join A with B like this. One vector we got. And join A with C. Another vector we got. And join A with D. Another vector we got. So how many vectors are there in the plane? 3 vectors are there. So 4 points, nothing but 3 vectors. So now you see AB bar, AC bar, AD bar. Order is not at all necessary. All lie on are all lie on same plane. Lie on same plane. So coplanar points means they must lie on same plane. So this implies AB bar, AC bar, AD bar are all coplanar vectors or coplanar vectors. So their coplanar vectors means that box of AB bar, AC bar, AD bar is 0. Now I'm going to. So here are a few questions from previous JMA. The first question asked in 2019. Alpha belongs to R. Three vectors A bar, B bar, and C bar are coplanar. Here you see the set S equal to set of alpha such that A bar, B bar, C bar are coplanar. Means if A bar, B bar, and C bar are coplanar vectors, then how many elements S may contain? This is the question. So here is the solution. A bar, B bar, C bar are coplanar. So this implies box of A bar, B bar, C bar equal to 0, which means that simply determinant of these three vectors is 0. So you write the determinant. What is the first vector? Alpha 1, J component, K component 3. Second vector 2, 1 minus alpha. Third vector alpha minus 2 and 3 equal to 0. So now expand it. This implies alpha into, you see, this is 3 minus 2 alpha minus 1 into 6 plus alpha square plus 3 into, you will have minus 4 minus alpha equal to 0. We get this is minus 2 alpha square, you see, and this is minus 6 alpha square. So totally minus 8 alpha square. Sorry, this is minus alpha square. Minus 2 alpha square means you will get minus 3 alpha square. Now, how many alphas are there? Here, this is 3 alpha and this is 3 alpha and this is minus 3 alpha. It becomes 0. Minus 4 minus alpha. So, there is no alpha term. Now, what is the constant? Minus 6 minus 12. So, minus 80 equal to 0. So, this implies that 3 alpha square plus 18 equal to 0 is never possible since alpha is a real number, so has no real solutions. Has no real solutions. So therefore, that option B is correct. That set contains no elements. So that's why it is an empty set. Here, two questions. One question asked in January 2023 and another question in July 2022. Both are based on similar concept. So I'll solve only one question. Now you see, 4 points whose position vectors are given are coplanar. So remember the concept. A, B, C, D are coplanar. A, B, C, D. Points A, B, C, D are coplanar. This implies box of AB bar, AC bar and AD bar equal to 0. So assume this is OA bar. This is OA bar, first vector, and second vector is OB bar, and third vector is OC bar, and the fourth vector is OD bar. So therefore, this implies determinant of what is AB bar vector. Simply subtract OA bar from OB bar. Simply subtraction of numbers. So here you see, you will get minus 2, minus 2i. And here it is 2 and it is minus 4. So you will get 6. And next here minus 1, minus 2, minus 2. This is AB bar vector. Next AC bar vector. Subtract OA bar from OC bar vector. So here minus 2, minus 3, minus 5, minus 1 plus 4. So plus 3, 3 minus 2, 1. And next AD bar vector means subtract OA bar vector from OD bar. 5 minus 3, 2. There minus 2 alpha plus 4. Minus 2 alpha plus 4. And 4 minus 2, 2. This is equal to 0. So this implies, just expand the determinant, minus 2 times of, this is 6 plus 2 alpha minus 4, minus 6 times of, minus 10 minus 2, minus 3 times of, minus 10 plus 10 alpha minus 20 minus 6 equal to 0. Now they are asking what is the value of alpha. Very simple question. So this implies just only simplification part is left. So here you see this is 6 minus 4 is 2. So minus 4 alpha. And this is minus 12 into minus 6 plus 72. This is minus 30 alpha plus 26 into 3 equal to 0. So by simplifying this, you will get minus 34 alpha sending that side. So here this is 26 into 3, 78, 72, 150 minus 4. That is 146 equal to 34 alpha. So therefore alpha equal to, you will get 73 by 70. Question is finished. Option A is correct. So this is the question number 2 I have solved. So you please try to solve the next question by yourself using the same method. So here is another question, mixed bag, asked in January 2023. This is, so here two concepts involved in this. One is if the vectors are coplanar. So the first one is coplanar, given that coplanar. And after that, they are asking the projection of A bar on B bar is root 54. Then sum of all possible values of lambda plus mu. Here they have given two parameters, lambda and mu in vector A bar. So in order to determine two parameters, lambda and mu, we need two geometrical conditions. So here given that two geometrical conditions, one is coplanarity of points, another one is projection of one vector on another vector. So Here, what is the part 1? So part 1 is A bar, B bar are coplanar. A bar, B bar, C bar are coplanar vectors. Are coplanar, right? So therefore, determinant of what is the first vector? Lambda, mu, and 4. Second vector 2, 4, minus 2. Third vector 2, 3, 1. So we just expand the determinant. We will get a relation between lambda and mu. An equation in terms of lambda and mu. Lambda into 4 plus 6, 10. So 10 lambda. And here this is 2 plus 4, 6 minus 6 mu. And what is the constant now? It is 6 minus 8 minus 2 into 4 minus 8 equal to 0, implies dividing by 2, 5 lambda minus 3 mu minus 4 equal to 0. This is equation 1, coplanarity condition. Now, part 2. This is part 2. That here you see projection of A bar on vector B bar is root 54. So projection of A bar on B bar is given as root over 54. So which means that the projection of A bar on B bar is A bar dot B bar whole by modulus of B equal to root over 54. Well, so we will get so A bar dot B bar is nothing but lambda. This is 2 lambda plus 4 mu minus 8 equal to root over 54 into what is mod B bar? Mod B bar is nothing but root over 4 plus 16 plus 4. So by simplifying this is you see root over 54 means 9 into 6. So 3 root 6. This is root 24 means 6 into 4, 2 root 6. We get that 2 lambda plus 4 mu. This is 36. So you will get minus 44 equal to 0. Dividing by 2, you will get lambda plus 2 mu minus 22 equal to 0. So this is second equation. We just need to solve these two equations, both 1 and 2. So what we have to do is multiply second equation by lambda and subtract equation 1. So 2 equation 2 multiplied by 5 minus subtract first equation. Now you see 5 lambda cancel. Here this is 10 mu plus 3 mu. You will get 13 mu. And this is multiplied by 5. So minus 110, right? And plus 4. Minus 106 equal to 0. So we got that lambda mu equal to 106 by 13. Okay. So this, therefore, we want lambda plus mu. sum of all possible values of lambda plus mu. Lambda plus mu equal to, here what is the lambda? Lambda is 22 minus 2 mu and plus mu. So this is equal to 22 simply minus mu. Maybe here the vectors I have taken little wrong. That's why my answer is not matching with this 24. But without, by removing these options, we got this value. This is equal to 22 minus 106 by 13. So you please simplify this. So whatever it may be, but the procedure is same. According to the question, we have solved the problem. So if any numerical changes, according to that, we will get the answer. Maybe here I have to take -2, but yeah, no problem at all. So here options are not at all matching. So here is another question. Here given that A bar, B bar, C bar are non-coplanar vectors. These are non-coplanar vectors. Means I, J, K are non-coplanar vectors. Let the position vectors of 4 points A, B, C, D are given respectively. If AB bar, AC bar or AD bar are coplanar vectors, then what is the value of lambda? So they are coplanar vectors, which means that AB bar, box of AC bar and box of AD bar vector equal to 0. So this implies box of, here you see what is AB bar vector. Subtract the first point from the second point. So you will get lambda minus 1 into A bar and minus 2B bar. This is minus 2B bar and 4C bar minus C bar plus 3C bar. So this is one vector. And next, and what is AC bar vector? Here minus A bar, minus A bar, minus 2A bar, 2B bar, minus of minus plus 3B bar, minus 3C bar plus minus C bar, minus 4C bar. Next, what is AD bar vector? 2A minus A bar, minus 4B plus B, minus 3B bar vector, and 6C bar, 6C bar, minus C bar, plus 5C bar vector. This box equal to 0. So this implies simply this is equivalent to determinant of lambda minus 1, minus 2, 3, A bar component, B bar component, C bar component. Minus 2, 3, minus 4, 1, minus 3, 5 equal to 0. Since here A bar, B bar, C bar are non-coplanar vectors. You just simply think like A bar equal to I cap, B bar equal to J cap, C bar equal to K cap. They are non-coplanar. So you just expand, you will get the answer. So here is another question asked in January 2023. The vector A bar is rotated a right angle. A vector A bar is rotated right angle. Suppose a vector is like this. It is rotated by right angle. Passing through y-axis. Passing through y-axis. In its way, and the resulting vector is B bar. Asking what is the projection of 3A bar plus root 2B bar on another vector. So that is another concept. So first you say, assume this is z-axis and this is x-axis and this is y-axis. Now assume this is a bar vector. This is a bar vector. Now the resultant vector is b bar vector. This vector is b bar. Now we have rotated a bar vector by an angle 90 degrees like this by crossing y-axis. You see, passing through y-axis, passing through y-axis. So here what is the concept? Here you see the magnitude of a bar and magnitude of b bar equal, right? So the very basic point, first one is magnitude of a bar equal to magnitude of b bar. First observation. What is the second point? A bar, comma, y-axis, comma, y-axis is nothing but j cap, b bar, or coplanar, or coplanar. What is the third point? Right. And what is the third point? You see, a bar is perpendicular to b bar. So b bar is perpendicular to a bar. This implies a bar dot b bar equal to 0. So we will use these three conditions to determine the vector b bar. So here we take that b bar equal to, let b bar equal to pi plus qj plus rk. We will use the first condition. Using the first condition, mod a bar equal to mod b bar. So therefore, squaring both sides, you will get p square plus q square plus r square equal to magnitude of given vector a bar is square of magnitude is 6. Second relation or third relation, b bar is perpendicular to a bar. So we have that minus p plus 2q plus r equal to 0. Now what is the second condition? A bar, j cap, b bar are coplanar. So here I am writing. First I am writing y-axis 0, 1, 0. There is no order. A bar vector is -1, 2, 1. And what is b bar vector? P, Q, R equal to 0. So this implies, anyway, first one is 0, third one is 0. Means first element, third element in the first row are 0. So now it is left only middle element 1 into -1 into, you will get minus R minus P equal to 0. So this implies we just get R equal to minus P or P plus R equal to 0. So we got this relation, right? So therefore, here I am solving, substituting this R equal to minus P in third relation, right? So substitute this, put in 1 and 3. 1 and 3. So therefore you see, put R equal to minus P here. R plus R, 2R. So 2R plus 2Q equal to 0 implies Q plus R equal to 0. Right? This implies q equal to minus r or r equal to minus q. So from 1 we get, you see, p square means r square, q square means again r square plus r square equal to 6. So we get r square equal to 2. So we get r equal to plus or minus root 2. So when r equal to root 2, you will get q equal to minus root 2 and p equal to minus root 2. Or you will get the another vector, that is r equal to, if you take minus root 2, you will get q equal to root 2 and p equal to root 2, means parallel to that vector. So here, therefore, what is the vector b bar? B bar vector equal to, if you take p equal to minus root 2, so I can take root 2 common. So minus I minus j plus k, or root 2 into, you can write I plus j minus k. Anyway, these two are parallel. And now what else is left? We will find 3a bar plus root 2 b bar. So what is 3a bar plus root 2 b bar? This is equal to 3a bar is minus 3i plus 6j plus 3k. And root 2 b bar, I'll take one vector. So minus 2i minus 2j plus 2k. By simplifying this, you will get minus 5i plus 4j plus 5k. So we got here this, or this is minus 3i plus 6j plus 3k. What is the second vector? You substitute, you will get 2i plus 2j minus 2k. So we get this is equal to minus I plus 8j plus k. So now we need to find out the projection of this. So projection of 3a bar plus root 2 b bar on c bar vector equal to 3a bar plus root 2 b bar dot c bar by modulus of c bar. You just write the, you just apply, you take both the vectors and find dot product. Whichever is there in the answer, that you take.